Beautiful. Now I'm going to go back so that everyone can see the slides that I've just pulled down. Excellent. Okay, so the first thing I'm going to say is thank you to everyone from wherever you may be in the world joining us. My name is Joe Duggan, and also with me today is my colleague, Graham Walker. Graham, do you want to give everyone a quick wave?
G'day everyone, thank you very much for joining you. I'm coming to you from a rainy, cold Canberra, so I hope the weather is more pleasant wherever you are.
And I do want to point out today that Graham and myself are zooming in from Ngunnawal land, and they were the traditional owners on the place where we are, and we want to acknowledge their elders past, present and emerging, and thank them for allowing us to be on the land.
Yeah, can I just echo that
please.
Acknowledgement of country, Joe? I just wanted to echo that and acknowledge the Ngunnawal people. They were the first scientists that, or I'd call them scientists, what they call themselves is up to them, but they were the first scientists, they were the first innovators, they were the first people to start looking at nature in the country that I call home and making sense of it and finding out how it was relevant to them. So I'd like to acknowledge the elders past and present.
Brilliant. Thank you very much, Graham. I've just got a question on the chat there that I'll answer now that we have everyone with us. Will there be certifications for the workshop? For people that participate in multiple workshops, then certainly that is something that we're investigating. If there is interest from everyone to receive certification or formal certificates as part of this, that's something that we would love to do. Now, I'm going to check to make sure we don't have anyone in the waiting room waiting to come in. No, excellent. All right, we're going to kick it off. You are all joining us today to participate in the very first workshop of Hands-On Online Science Asia Pacific. This will be one of several workshops that we're going to run over the next few months, and I would love as many of you as possible to participate in subsequent workshops as well. As I said at the outset, you are all on mute, but that does not mean that we don't want to hear from you all. The middle line there says, use the chat function if you have any questions, and particularly when Dr. Walker's talk or lecture or workshop starts, I will be there and you can get in touch with me if you have questions, and I will send them over to him. The other thing to note is that our recording sessions, the things that I'm capturing now, I will actually put that on YouTube, provide links so that people that want to watch it after the fact, or people that can't come along, you can see it in your own time. And the other thing that I really wanted to point out was that we would love for you to follow us on Facebook. We want a way of staying in touch with you. The way that we think has been effective in the past is to actually follow us at ANU Science Circus on Facebook. That way we've got a way to keep in touch with you, keep you updated on what's happening. I've talked a lot. One thing I wanted to, before we actually jump into some of the nitty-gritty, I was about to tell you what Science Circus International is. Now, some of you have worked with us before and under different guises or different banners, but I actually wanted to get hands-on and show you some of the work that we do. So I'm going to stop sharing for a moment, and I'm going to go to this view in the hope that everyone can see me, because I want to do something now. I want to showcase to you what it is that Science Circus International is all about. Now, one thing to point out is that a mission that is very close to my heart is that science doesn't have to involve or use complex materials. So here I have a glass of water, and I'm just going to put some water into this cup here. Now, some people in the chat are saying share the links of Facebook and YouTube in the chat so that you can subscribe. I certainly will do that. And I'll do that once Dr. Walker's or Graham's workshop starts, when I've got some free hands. So what I've got here is a simple glass of water. Now, in the chat, I want you to type what you think will happen if I turn this cup of water upside down. Type whatever it is you think will happen. Will the glass burst into flames? Will the water hit the ground? Will I make a mess? There is a risk that I might make a mess, so I've got a bucket here and I'm going to put that below me. Now, one thing that we love to convey in the science that we do, someone said a fail. Yeah, it could well be a fail, and I will say that I do fail regularly in doing science, but that's another message that we want to convey, is that you don't always have to be right or get the right answer when you go through the scientific process. In fact, what we want to do here is quite often be wrong or make mistakes, because that is an opportunity to learn. So the first thing I'm going to do is tip out some water, or at least turn my glass to the side. And yes, a whole bunch of water did go to the ground. Okay, so, and I'm actually already seeing a whole bunch of scientific terms in the chat there. Water will fall down because of gravity. The water will go towards the ground because of a force. All very true. I'm now going to do something that we do in science all the time. I'm going to do this experiment again, but I'm going to change a variable. Now, the variable that I'm going to change when I turn my glass over is I'm just going to put a plate on top. I'm going to do this experiment again, and we're going to see what happens. So just like before, turn the glass over, except this time I've got the plate stopping the water from coming out. The crazy thing is I can actually take my hand away. And if you look closely, you'll see the water's still inside the glass. The plate is still attached to the glass, and I haven't made a mess yet. Now, I won't hold it for too long because I am holding it over my laptop and I don't want to destroy any electronics during this workshop, if that's okay. Now, the reason this happens is because there's about 11 kilometers of air above us. Okay, and this air is pushing in every direction. We don't feel it because we're used to the air being around us and pushing in every direction. But this demonstration actually gives us the opportunity to see it in action. Because when my plate is upside down, or my cup is upside down, and my plate is on it, that air pressure that is pushing in every direction is pushing down, sideways. It's also pushing up underneath my plate. And it's that air pressure pushing up that holds the plate on. Now, that's a very basic explanation. And let's say I was talking to you as secondary school students. I might talk about the difference in air pressure, or something like surface tension or adhesion and these properties of water. But what I'm trying to do here is show you that we can explore science with very simple materials. And this is right at the center of the work that Circus International does. And it'll be a theme that keeps coming back throughout our workshops. Now, I'm going to go back and share my screen. Dr. Graham, I keep going to call you Dr. Walker. Graham is going to come back into the frame. And Graham, I'd love you to tell everyone a little bit about what Circus International actually is.
Wonderful. Thank you, Joe. So as Joe just showed you, we can do amazing science with really simple items. We can connect that science to the things we're teaching in schools and the curriculum, and we can connect it in other ways to people's cultures, to the places people are. We can make it relevant. So we try and do that in Circus International, but at the heart, the work we do through the Science Circus all around the world, it started back in about 2003, working with a lot of countries in Africa. We've since started working in lots of other places, including in India, Timor-Leste, right through the Pacific, so lots of different places. And what we try to do is partner with local organisations, local people. It could be teachers or universities, could be anyone who wants to learn kind of more innovative ways of teaching science, particularly where we're teaching with very simple items, or maybe they're wanting to take science out of the classroom into the community, run after school programs or build science centres. So we partner with a range of people, a range of organisations organisations to try and help them fulfill those kind of objectives, and it's taken us all around the world, and it's let us meet some amazing people. One thing we are finding in this pandemic, we're not meeting so many people in your beautiful countries. I wish I could be traveling to all the places represented today, because I know there's a huge diversity, but what it has let us do is connect with people in new ways, and hence we'll be running these series of online workshops. We've got another series of workshops around climate change. So if you want to connect with us, hopefully we can come and visit you one day. But until then, it's wonderful to see everyone here online.
Beautiful. Thank you very much, Graham. And then I suppose we better talk about what it is that we're doing as part of this educator series.
So this is the first in what will be, I think, 5 or 6 workshops. So jump on the Facebook group, keep an eye on your emails and things like that. There'll be a whole series of these workshops. They're a collaboration between us at the Australian National University. We're at a place called the Centre for the Public Awareness of Science, which is where we do science communication at the Australian National University. We've been very fortunate to partner with our good friends and colleagues over at UNESCO at the regional office in Jakarta, and I'd like to acknowledge and really thank the UNESCO team for helping us put together this series. So thank you very much.
Excellent. So in a little bit more detail, essentially what we want to do over the next 3 to 4 months is deliver a series of free online workshops for teachers across Asia and the Pacific. And we want to focus on STEM teaching online. Now, we acknowledge that that's a very broad area, but what we do want to point out is that there will be useful things for any teacher across Asia Pacific there, whether they're teaching remotely, whether they're producing things for online, whether they're teaching in the classroom in front of students, or anywhere on that spectrum. We're actually going to cover today with Graham some activities and some hands-on workshops on relevance, that is how to make STEM relevant. We will explore some inquiry learning pedagogies in subsequent weeks. We're going to think about how you as teachers can create these similar sort of activities, but also how can you capture them? How can you record them, film them, distribute them, apply them in the classroom? We're also going to look at some tinkering, some other hands-on elements of STEM, and we're also going to investigate how to put the M in STEM. It's often something that gets forgotten, but this idea of maths being one of the STEM subjects, and how do we explore that in an engaging way? Now, the next thing that I want to say is that I keep going on about this, but we want to learn from you too, and we want you to learn from each other, which is a huge part, really key, a really key element of the work that we have done all across the world. Is it starts with acknowledging that, well, Graham and myself, we're both outsiders to whatever your local context is. Yeah, I grew up in Australia. I grew up with the Australian education system, but I'm unfamiliar with the Samoan education system, with the education system in India or Pakistan or Sri Lanka or Fiji. And we want to acknowledge that you are actually the experts in those areas. So to help facilitate some of this knowledge sharing and some of this networking, we're actually going to create a specific Facebook group that is closed just for the participants of this series and a subsequent series that we'll be running as well. And that'll be a place where we can offer you tailored support, but also put you next to like-minded teachers, educators, researchers. The other reason that I would say it would be a great idea to go along and become part of this closed Facebook group is because that's where we're going to be telling you about competitions and other ways that we can offer support to yourself as teachers within your home countries. And as part of this workshop series, we want to offer micro grants or prizes to passionate teachers that can show us how they're implementing some of the things they're learning in these workshops into the classroom. Okay, before we jump into Dr. Walker's lecture, Graham's lecture, I really want to try one thing. Now, this is a new way of interacting with everyone, but if anyone has a phone with them, or if they want to open up another browser on the laptop or the computer that they're talking on, that they're watching us on, can you go to slido.com? Now, we spoke about putting this in the chat. What I will do is put something in the chat that will let you click straight on the screen and go to the website. Now, if you click on this link, it should take you straight to a website that you can then enter the code that you see on the screen. Because we're going to do a little bit of a survey. I'm going to stop sharing that screen. I'm going to share a new screen. Okay. So now everyone should be able to see the screen that I have up at the moment. I'm going to go back and move a few things around so that we can see it. Okay. Now, if you go to slido.com and you enter the code that you can see on the left-hand side of the screen there up the top, SCP1, or if you have a QR code reader on your phone and you scan the QR code that you see in the top left-hand side of your screen, you'll actually be able to go in and answer the question that you see in front of you. So we've got a few people voting at the moment. Now, if you're having any challenges, you can let us know in the chat. The other thing that I can do is find a link that is going to get us all there a little bit easier. Now, I'll put this one in the chat when I find it. Well, we've got a few answers coming in now. We've got quite a few teachers, some educators, and some others. And that's great because we want a diverse range of people participating in this workshop. Oh, we've got some people saying the code isn't working. Well, what I can do is see if I can give you a direct link. Graham, you might be able to put into the chat the link that you sent through earlier that'll actually let us go straight to that page.
Roger that, Joe.
Thank you very much. So we're getting more in now. And look, what this is telling us is that a lot of what we'll frame our work around, particularly today, is the teacher context, because a lot of us in this workshop at the moment are, in fact, teachers. Yep, we're getting a little bit more feedback saying the code doesn't work, and that's fine because Graham will send through a link in a second, which will mean that you can click that link directly and you'll be able to go straight in.
Okay, so I've put a link into the chat and that should hopefully take you straight there, and you won't need a password either.
Beautiful. So we'll get everyone to try that. Graham's just put it in the chat there and try this link. You should be able to click on that and that will take you straight into the survey itself. And then we should be able to see everyone's answers once we get the right page open. Okay. So a few more responses coming in here now, and I'll pull it up for you so you can see. Now, excellent, it's working now, beautiful. So we're starting to get more of those responses in. Oh, we've actually got some science communicators in the chat as well, great to see, but predominantly teachers. Right, now I have one more question that I would love to ask you, and that is, where are you joining us from? So you'll see on your phone now a new question will have come up, or the screen that you were looking at. Just type in the location. You can do country, state, region, hemisphere. Let us know. We've got some Samoans, Pakistan. Great to see. Malaysia at home. Great. A lot of us are working from home at the moment. It's a very strange, very new normal that I think we're slowly getting used to.
Well, it's just wonderful to see people.
Sorry, Graham, you cut out there. Do you want to try again?
So it's wonderful to see people from all over the region. And I think the thing we're going to be talking about today, relevance, it all depends about who you are or where you're from, what you think's important. So it's going to be very interesting to see how everyone connects with the science differently.
We do have a huge spread here, from Samoa to Indonesia, Pakistan, the Philippines, all these beautiful places that I absolutely wish we could travel to. But for now, we need to be happy with talking through the computer screen. Thank you so much for sharing, everyone. I hope that this process of jumping in and out of various platforms and asking you to contribute, that's something that we can incorporate into every workshop that we do, so that we can get everyone's insights. Okay, now I am going to quickly just check. We've got a few more people coming, and I'm just inviting them in now. What I am going to do is share our screen again, and we can actually start our lecture, today's focus, with Dr. Walker. So Graham, would you like me to have the slides up at the same time, and then everyone can adjust their screen so that they can see you and the slides?
Yeah, that sounds like a good idea, Joe. Thank you.
Beautiful. So let me quickly do that.
Fantastic. Just while those getting the technology to behave itself, thank you everyone for tuning in. We are going to talk about the idea of relevance. You may have been teaching a class where you looked at the audience and you thought, wow, I'm really connecting with them. There might have been times when you're teaching or communicating and you look at your audience and you realize that you're not connecting with them. So relevant and making sure our teaching and our communication is relevant is so critical, and we're going to talk about that in a little bit more detail. Now, we are going to talk about it briefly at the start, but then we're going to be doing a whole lot of activities that you can hopefully use yourself. They all use common everyday items, and if you did bring along any of the materials to try them, I'd really encourage you to try them yourself, either during the session as we go along or afterwards. But we are going to talk about relevance, and relevance is a word that we use a lot. It's got a kind of everyday casual meaning, but it also has I guess a more precise meaning, and it's understanding relevance in this deeper way that can help us really connect our science content with our students' passions, what they think is important. And if we can do that, if you can be relevant, then it really has big impacts on how students learn, and also how motivated or inspired your students are. So we might jump into the first slide, Joe.
Brilliant. Now, I will just say to everyone, you should be able to move the video screen so that you can have a big picture of Dr. Walker alongside the slides. That way you can get the best of both worlds, as they say.
Wonderful. Look, so, you know, you can go into the academic literature as I did. So I learned all about relevance during my PhD studies. One of the things I'm very passionate about is using science demonstrations and kind of making science into a bit of a performance. And I wanted to find out, well, I want to know how to be relevant, because I knew that relevance is something that really motivates people and really inspires them. And for me and the kind of teaching that I do, obviously we want people to learn the science, so there's that knowledge, but a lot of the work I do is just as much about motivating people, particularly young people, trying to help foster positive attitudes towards STEM and trying to do things that are more over in that kind of emotional, psychological area and not so much to do with learning. But the bottom line is relevance will help both those things. It will motivate people and it will help them learn better. So it's a really critical thing to make sure that our STEM teaching has. So what is it? You'll see a little Venn diagram up there. And this is a really simple but really accurate way to kind of start thinking about what relevance is. Now, over on the left, you'll see a green circle, and that represents everything in our students' lives, okay? Their day-to-day things they're doing, their hobbies, their passions, the things they're doing at school, everything in their life. On the other side, in the blue, we've got the STEM content that you're teaching or you're communicating. Now, at some point in the middle, those things are going to overlap. So there's going to be things that we're teaching where the student can go, oh yeah, that reminds me of this thing I did the other day, or oh, that will be some great knowledge. I'll be able to use this for something in my everyday life. So in that middle bit where those two circles are overlapping, we've got things that are relevant. Now, we can break down relevance a little bit further, and Joe, if we can jump to the next slide. The amazing thing about relevance, and also the really challenging thing for educators and communicators, is that relevance is really up to the individual. So what's relevant to me will be very different to what's relevant to you, or you, or you, or you. Everyone's version of relevance is going to be a little bit different, and it depends on lots of things. We all have different everyday lives. Here it's raining, so it's really relevant that I didn't bring an umbrella today. But where you are, if it's sunny, that might not be an issue. So when people are judging relevance, they do it in different ways. Most fundamentally, it just connects with our everyday life, but it might also connect with our prior knowledge or our experiences, things we've done before. And that could be things that they're learning in other subjects, or could be things from out of school as well. So say linking to pop culture. I know in Australia and certainly in the Pacific, sport is very, very, very relevant. And often we'll try and connect our STEM learning to our sport to try and bring that relevance. So connecting with people's hobbies and interests, these are all ways we can make things relevant. Getting down to when we can provide content that is useful to people. Now, this is a more potent form of relevance, and I hope during the workshop today, you're going to see activities and you think, wow, I could put that into my teaching straight away. Then I've given you something that is useful, something you can take off to another part of your teaching or your life, and you can use this information. So this is a more potent form of relevance when we can help people with their needs and we can help people achieve their goals. And all your students, they've got goals, short and long term, and we can help match our STEM content to that. Now, getting deeper into more what makes us up as individuals, this is where relevance starts to become more powerful, okay? When we move from just being useful to really connecting with people at a deeper level. Now, this is the thing that makes relevance a tricky thing to use in science education, in STEM teaching, because it's a really personal thing. So I might try and connect with people's culture or where they live. I might try and connect with gender, because that's something that's really intrinsic to a person. If I'm trying to motivate a young group of young female scientists, I might use an example of a wonderful female scientist like Marie Curie to try and connect with them, because I think it might connect through, their gender and their identity as a young woman. So demographics can be a great way to make things relevant. And really, your students a whole lot better than me, so you're the experts there. On a really deep level, we can connect with things that are really dear to people. So connecting with people's culture, connecting with people's Indigenous knowledge, things that really embody the nature of that person. So you can start to see that making science teaching relevant can be a pretty tricky thing, because we really have to understand these quite deep things like culture. And as Joe said at the start, as an outsider, I've been able to witness many different cultures around the world, but I can only really understand my own. You're the experts, but you're the only experts on your own culture. But if you can connect your science to these things that are really deep in people's lives, then it really helps them to get engaged. So you'll see a little arrow on the left there, a big green arrow, and kind of the further we work down that list, the more impact we get from this relevance. And as I said before, the impact could be in more effective learning, because when people can connect what they're learning to their past learning, information they've already got, then they're going to absorb that information much more clearly, okay? If we look at constructivist series of learning where people are building new knowledge on top of old knowledge, obviously relevance is a really critical thing there, so people can start to learn in that constructivist way. Relevance is also really, really critical for motivating people and keeping them interested, okay? You've all seen students, I certainly have, who you're working your hardest and they're just not interested, okay? The content is not connecting with them. And if they're not interested, you can be pretty sure they're not learning. So these kind of more effective or emotional things can be just as critical as the actual knowledge and the content that we're trying to teach. One thing I should say is that you can be relevant for the wrong reasons as well. So obviously in a classroom, we're trying to use relevance in a way that it's going to be positive and motivating. Relevance can be a negative thing as well. So when we're trying to find examples or context to put the science in to connect with people's everyday lives, we need to think about whether that's going to be a positive and negative thing. And I'll give you an example I found quite profound. I was doing a show in Jordan, in Amman, in the Middle East, and I had a show that had lots of explosions and things, because the kids love, things popping, and there'll be some explosions in this show, or in this workshop. And the people at the Children's Museum in Jordan, they said, the next group that's coming, they're all orphans from war-torn countries elsewhere in the Middle East. And I had to rapidly think, wow, I've got these things that explode. I've got these things that might trigger really, dark memories and things for this group of kids. So in that way, relevance could have been a negative thing. And I was able to shift the way I was highlighting that relevance to try and make sure that I didn't upset anyone, didn't trigger anyone. So just remember that relevance can be a positive and a negative thing. Most of the time, it's positive, and that's what we're here to do today. Next slide, Joe. I did notice some people out there that might be interested in the more academic end of this, and there's a lovely paper which we'll be happy to share with you. I'll put a link in the closed Facebook group. But this is a paper that shows relevance on a continuum, okay? And we start with what they call personal association, just like, oh yeah, that reminded me of something. But then we move on to actually making the science useful for people, okay? Now, I hope I'm going to be relevant in that way today. I'm going to give you some ideas that you can use in your classrooms. Finally, on the end, we've got what they call in this paper identification. So this is where we're connecting in a really deep way. We're connecting to those things that people hold dear. We're connecting to those things that actually make up that person, okay? Their identity, their culture, these deep things that really define us. So we can do this in our science teaching. We can take things we're teaching from the curriculum, we can put them into different contexts, we can find different examples, and we can help make our science relevant. Now, I actually have taken some guesses at what will be relevant to you today. I've had to think about who's coming along I've had to think about some of the schools I've visited around the world. And one thing I know is whether it's a school in Australia or a school in South Africa or Myanmar or lots of other places, no one ever has enough budget. We certainly don't here. So the first way I'm trying to make this relevant is by using everyday items that I hope are going to be really easy for you to find and really cheap for you to find. So hopefully that is a way I've been relevant today. The other great thing about using everyday items is that students already find them relevant. Okay, so they can look at this. It's not a fancy piece of lab equipment. We don't have to call it, you know, a volumetric flask or something. It's just a Coke bottle, and people can immediately relate to this. So using everyday items in your teaching, it's a good way to be relevant, but it's also a good way to keep your budgets down. So they're two things that I'll be doing today. Now, that's a really, I guess, a simple version of relevance, okay? Probably not good for our health system, but everyone can relate to this Coke bottle, okay? It's relevant to everyone. If we want to connect in different ways, we have to really start understanding who we're talking to. So Joe, if you can go to the next slide. Now, we have got a wonderful diversity of people on the Zoom call, on the workshop today. And I actually, this is the first time I've met you all. Hello, everyone. But the problem for me is I really don't know what's relevant to you. Okay, I've got a bit of an idea. They're all teachers and educators. They've come to learn about doing hands-on science online. So I've got a rough idea what might be useful. But beyond that, I don't know you well enough to be relevant. So what I'm hoping we can do as we go through these activities today is for you to use the chat to actually tell me and tell Joe and to tell each other what is relevant. Now, after each demonstration, I'll prompt you, and Joe knows I get excited when I'm doing these demonstrations. So if I do forget, I'll ask Joe to remind me. I want to know what you're finding relevant in here. It might be how a certain demonstration links to everyday life where you are, okay? Not in Canberra, wherever you are. It could be useful, okay? You could look at that and go, oh, wow, you know, we could use that to, so solve some kind of problem we're having in the community. Or it might be useful because you're teaching STEM and you wanted a hands-on activity. So I want to hear how it's useful. Now, finally, I want to hear how it's connecting with your identity. And this is the part that Joe and I would really like a lot of your help with, because we're not experts on your culture, where you live, what the local issues are, what you hold dear, what you think is important. So we really want to know how this connects with you. Now, I've asked you to go through this exercise, how you link it to everyday life, what's useful, what links to your identity, because if you can do a similar thing when you're designing your lessons and you're selecting hands-on demonstrations for your students, you're going to be one step closer to making your STEM teaching super relevant. So after each chat, and feel free to use the chat for anything. There's also reactions, hand clapping. I'm not sure if there's a boo emoji, but tell us how you're finding it, whether you like it or not. But we'd really love to hear how you're finding things relevant. All right, we might, just before we go into the demonstrations, I do want to tell one lovely story of relevance, and also a story of how relevance is really different for different cultures. And this is something working internationally that I really love. I love seeing how people interpret the science. Joe, can we have the next slide? Now, this is slightly awkward to tell this story. Usually I'm telling it to a room full of people where I can see everyone close up. I'm actually glad that I can't see you too closely, because this is a slightly embarrassing story, but I'm going to tell it anyway. This is a story, picture in a school in South Africa where the Science Circus has done a lot of its work and where we started off. And in the ANU shirt is my colleague Christy. The other gentleman in there, his name is Dumasini. Now, the demonstration, you might have seen it before, but you've essentially got a bowling ball. You can try this with a tennis ball or any other weight. Got a bowling ball hanging from the ceiling. You imagine there's a bowling ball here. We've lifted it up and then we let it go, and it'll swing backwards and forwards like a pendulum. Okay. Now, in the demonstration, you bring that ball right up to your nose and you let it go. Now, as energy is conserved, the ball will swing But when it swings back, some of that energy has gone into moving the air out of the way, so it'll never come quite up to where it is. But it's really exciting because the ball comes almost to your nose, but not quite. Now, how did we find this relevant? When I did this demonstration, the kids would think it was exciting. They'd be, all lots of excitement. The ball almost hits the nose, and some great opportunities to teach Newton's laws, to talk about energy. But when Dumasini, my South African friend, did it, and he was doing it in isiZulu, so one of the wonderful things about culture is that with culture comes language as well. And he would be doing it in isiZulu, and I couldn't understand him. But when he did it, the kids would learn all the science, but they would also laugh and laugh and laugh, okay? And I thought, hey, I'm meant to be the doctor that has all the information. I'm meant to be good at this. But they would not laugh at me. They wouldn't laugh at me, but they would laugh at Dumasini. And eventually I said to him, I said, what are you doing so that all the children are laughing? Because I wanted to learn from him. And he told me that he was telling a story that I was in South Africa, in Zululand, where everyone has quite a flat nose. And he was telling the students in isiZulu, so I couldn't understand, he was telling the students that I had built a physics machine to try and squash my nose so that I would fit in more with my friends in Zululand who have the flat noses. So it really hit home to me that there are so many different ways that a science demonstration could be relevant. And Dumasini, he connected it to energy, connected it to these things in everyday life, but then he connected it in this story. He connected it to something that was, I guess that the whole audience could relate to, okay? The shape of their nose, something that was something about them as people. And the students loved it. And it really got me thinking, well, relevance is such a personal thing, okay? This was a story that Dumasini could tell in this one place in Zululand to have this impact. And it really hit home to me how powerful relevance can be. So, nice little anecdote. I think we should do some science. Lovely. Joe, you can take those slides off now. Wonderful. So I've selected about 6 or 7 demonstrations here, and they all use really simple items. I tried to pick some that I think can be linked to everyday life. How they'll connect to your life, I'm not sure. So I'm hoping to hear that in the chat. But this very first one, we're going to make a little cloud in a bottle. Now, obviously the weather is something that is in the curriculum, water cycle, all of those kind of things. So nice ways we can connect this to the curriculum. There might be other ways that you can connect it as well. So you want to start off just with a soft drink bottle, or even a water bottle will work. We want a plastic bottle because we're going to squeeze it a bit later. You'll notice I've got a little bit of water down the bottom. Now the water is important for a couple of reasons. If we're going to make a cloud in the bottle, we're going to need some water to create that cloud. So start by just shaking it around, and that just introduces a bit of water vapor into there. Now, when clouds form, they actually need something to form onto. And we're going to use the smoke from a little match to do that. Let it get burning nice and well. Then we're going to pop it in there and put the lid on quickly. Now, what that has done is it's helped just a tiny little bit of smoke to be collected in the bottle, and those little smoke particles are where the water that's in the air are going to condense onto. And the same thing happens up in clouds. We have little bits of dust, bits of pollution, stuff up in the atmosphere that the water can actually condense onto. Now, to get our cloud to work, and I'll bring it out here, get our cloud to work, we're going to squeeze it really, really hard as you can, and then have a look what happens when we let it go. Okay, so you can see that cloud forming. As I squeeze, you'll see it go clear. As I let it go, you'll see that cloud form, okay? So inside the bottle, with the lid on, as I squeeze it, the pressure gets very high. As I release it, there's a rapid change in pressure, And with that change in pressure, we get a change in temperature as well. There we go. So very simple demonstration to create a cloud, very low cost, and you can use it in lots of different areas of teaching. You might want to relate it to weather and things like that. There might be other parts of the curriculum around pressure, condensation that you could also link it to. Now, before we go into our next demonstration, I will ask everyone to those questions I asked you before. If this has linked to everyday life, let me know. I'm sure we've all got clouds. But what we're really keen is to hear how it might be useful and how it might link to you in a deeper way, how you might actually identify with it, whether it's, you know, connecting with a really unique local story, whether it's connecting with your culture. So if you've got, I'll give you all a few seconds just to reflect on that.
And Graham, just whilst you're counting on your fingers, I've put those questions into the chat as well. So if anyone types back, I'll be sure to let you know.
Wonderful. Okay, and you can pop that in the chat. If you have an epiphany later on and you want to pop it in, we'd love to hear how it's linking to you. But a lovely little demonstration, and particularly I know a lot of people are doing things on climate change. We will have another series of workshops on climate change a bit later in the year. So hopefully we can see some people there. Now, I just want to ask, if you are sitting there and I can see your little boxes, feel free to turn your cameras on. I always like to see people. And I particularly ask if anyone's actually trying the demonstration where you are. I know some people might have some gear with them. Please show us what you're doing. And you can play along at home. If you didn't bring things to do it, that's all right, okay? Or you probably pick one of these up off the ground on the way home. That's where I get a lot of my equipment, is out of rubbish bins. And then you just need some matches. So really, really simple demonstration to show that process of cloud formation. Now, something else we can do with the same bit of equipment, we're going to get rid of that bottle. And I've got another bottle. Now you might notice this bottle is absolutely chock full of water. And we're going to do a lovely little demonstration that links to the one, the past one, in that we're going to be talking about pressure. We're going to see some really different things. Oh, I can see some more faces. If anyone else feels comfortable to turn their cameras on, oh, it's lovely. Look at all the people. Hi. Okay, wonderful. All right, so we're going to do another little demonstration that looks at pressure. Now, one of the things I really love about using everyday items to do our science is that it really highlights that there's lots of different ways that we can make our equipment, okay? Often the way a demonstration is put together and the equipment that we use, it will have relevance in different ways. Now, I'm going to make a little diver, okay? It's called a Cartesian Diver. You might have made one before. They're a bit of a classic science toy. And I've actually got, I've got a few different versions of my diver. You'll see this one, okay? Got this one here made from some plastic tubing and a bit of wire. I've got this one. Can anyone recognize what it's made from and pop that in the chat?
Whilst everyone has a think about that one, Graham, just on the previous experiment, there were a couple of comments from people saying that just the act of having something practical is a great way to hook the students in. And I think that's a very, very important point to note.
Absolutely. So I've got some different designs for my diver. Now, before I even get into looking at how the diver works, a few of you might know what this is, our little plastic straw. Now, plastic straws are relevant to different people in different ways, okay? As a science educator, they are really cheap, easy to get, easy to use, so maybe they're relevant in a good way, okay? If you're worried about plastic waste in the ocean, if you live on an island and everyone's rubbish is washing up on your beach and you're finding drinking straws, these can be relevant in different ways, okay? So just a good example of how just the basic things we're using can connect with people in different ways. In a lot of places, these straws are banned and we won't take them. I had some lying around and I've used them, but I wanted to show you these other versions. This one just made of a pen lid. This one just made of a piece of rubber tube with some press stick or blue tack on the bottom. And this one, again, just made of some rubber tube. You could use a straw, you could use any bit of old rubber tube you could find, and I've just got some wire to hold it together. So what we're going to do with this little diver is we're going to pop it into our bottle. And if you're using this for students, you want this to float really nicely. So if I drop that into the bottle, we've got two forces, okay? We've got the weight of those paper clips trying to sink, so we've got a force down. But in the straw, we've got a whole lot of air, okay? And the air is making it float or making it buoyant. So that's an upward force equal to the volume of water that we're displacing, okay? So we've got a force pulling down, another force pushing up. Now, you want that to be in balance. So if I pop that in there, you'll see it's just floating. You'll see it's just floating at the top. And do the same thing with my little, this one, and you can see it is just floating. I hope everyone can see that clearly. If yours doesn't float, it just means you'll have to get it out of the bottom of the bottle, so don't worry too much. But if it's really floating up like this, if it's too buoyant, you might not be able to squeeze it down. So let's pop it in here. We'll have a look at what we're doing. So in it goes. A lovely experiment to talk about buoyancy and pressure. Okay, relevant in the curriculum just about everywhere else. Take our bottle and we're going to squeeze it. Okay, give it a big squeeze. And you'll see our little diver go down and up. I'm going to bring this a bit closer to the camera so you can, down it'll go, up it'll go. So as soon as I squeeze, I apply a force to the bottle, and that force goes through all of the water, and it actually squeezes the bubble inside. So inside the straw, we've got some air, and as I squeeze, that bubble gets compressed, okay? As it gets compressed, the volume goes down, and a lower volume will mean less buoyancy, and down it sinks, okay? So at the moment, kind of buoyancy, the floating's winning. As I squeeze, down it will go, okay? So, lots of different ways we can connect it. I'll leave you to tell me how it's relevant. Let's just get this one out.
To provide an example for everyone, sorry, Graham, I was just going to say, to provide an example of some of the things that we're talking about when we say, how can we make this more relevant, or how can we connect it to a local context? I used to be a scuba diver. I used to travel around and usually go scuba diving in very cold water. But I love this demonstration because it shows how scuba divers can go up and down in the water. It also shows how fish can go up and down in the water without having to swim very hard. They have something called a swim bladder that operates much like Graham squeezing the bottle on the straw. So all of a sudden, we've got a way to link this not just to physics, but to biology.
Wonderful. Now, Joe, you just gave me a little bit of an idea how we can make this a bit more relevant for Joe. So I've made another, and you'll see this one has a little hook. You can actually kind of get this to go down in the bottom and hook things. But I think just so Joe finds this a bit more relevant, I think we're going to call this a little Joe scuba diver. Does it look like Joe? Got a couple of legs, and just put some little eyes on Joe. There we go. A little smile. All right, so we've got Joe, our scuba diver, and this will probably be a bit more relevant to Joe. It might be a bit more relevant to you as well, because you know Joe. He's a happy science communicator. We've got little Joe here, and we can pop him in here. Now, telling stories while we're teaching science is a great way to help highlight that relevance. Okay, as Joe just did then, told a lovely little story about scuba diving, and I thought, wow, what a great example of relevance. And those little stories, little anecdotes that you can add into your STEM teaching, showing a context in everyday life. And Joe did something without really realizing it. He was able to connect it to everyday life. But I also found out that I've connected this with Joe on a deeper level. So Joe, I know, is a very passionate scuba diver. So when he sees this, he's going to start thinking about, oh, I remember scuba diving, and I remember, you know, having to put on more weights to get down low and things like that. So without actually trying, I've connected with something that's quite relevant to Joe. Now, you might look at this as a scuba diver, feel the same way as Joe. You might connect it in other ways. But let's see if Joe can sink down here. I'm going to squeeze it. Down you go, Joe. And let it go, and up it'll come. Okay, so we can connect it to things around buoyancy. We can connect it to things around floating and sinking for younger years. But how we connect it in a deeper way is going to be up to you. I think one of the examples I often hear, Joe gave you a couple, is how a submarine works. So that's a good example of everyday life. I don't know about you, but I've never been on a real submarine, and I'm guessing most of your students haven't either. So a submarine might be a good example to connect with everyday life, but it's probably not going to connect on a deeper way unless, you know, maybe you're a scuba diver or you're a submarine pilot. So relevance is going to be different for different people. I'm going to test one more of my little divers, and that is the one with the pen lead. Okay, if you are making it with a pen lead, you need to block the little hole that is at the top of the pen. I've just blocked it with a little bit of plasticine. You could use blue tack or anything else you've got lying around, and we need a little bit of a weight on the end. Okay, if you're finding it's too hard to squeeze, you just need to add a little bit more weight. And this activity can actually translate really well as a longer kind of inquiry for students. They might want to test different weights of different weights that are helping it sink, and maybe different volumes of straws making it float. So there's good scope to expand this into a much longer activity, but it can also make a really nice little demo. Let's put our little pen lead one in there. I don't know if you're like me. I usually just throw the pen lid away, but this is a wonderful thing you can do with them, and you can actually make that into a lovely little diver as well. One of the other things you can use, and it's a great example of everyday items. You might have seen these little soy sauce containers. I had a little bit of sushi for lunch, and these can make great little divers as well. You put them in there, put the weight on the end, and block up where the sauce comes out, and you can turn the little soy sauce packets into lovely little divers as well. So once again, I'd love to hear how you found that relevant. Okay, for Joe, it was scuba diving, but I'm wondering what it was for you. So just as I'm cleaning up here, if you want to pop in the chat, how did you find this relevant? How might you make it relevant for your students? Then please pop that in the chat. I'm just going to give this a little wipe down while everyone is sharing their little relevant story. Wonderful. All right. So I can see, I can't quite read the chat from where I am and where my computer is, but I can see, I'm hoping.
Again, Graham, we've got some people talking about the importance of it being practical and hands-on, but also understanding that what we are trying to pull out there in terms of the science was the impact of pressure. So some really nice conversations going on in the chat there.
Absolutely. And I think one of the ways that I've found, I was just reflecting on my own question, you know, how did I find this relevant? At the moment, I'm trying to teach my 4-year-old to swim. He's quite a spirited little boy. and he refuses to use any of the things that help him float. He doesn't want the kickboard. He doesn't want the little floaties. So my little boy, when he's sinking, or sorry, when he's swimming, he's doing a lot of sinking because he doesn't have that buoyant force. And hopefully, if I can get him to wear the floaties, which he complains about a lot, then we'll see a bit more of him on top of the water than under the water. So again, a little way that I'm looking at this science, I'm thinking about it in the context of my own life. And I've suddenly got this really powerful story because I really want my little boy to swim, really want him not to sink to the bottom of the pool, so he can find relevance in very personal ways in the most simple things. And that relevance is what, I guess, it helps people understand how useful the science it is and how important it is. And these are great motivators in our STEM teaching. All right. Now I've got another little demonstration here, a little bit of chemistry. And once again, we're just using simple everyday items. So I've got some vinegar and some sodium bicarbonate, okay, baking soda. So both things that you can get anywhere around the world. In fact, I've got a little collection of baking soda from everywhere around the world, and it's a good way for me to go, wow, all these different countries, I can always get baking soda. I think here we've got some Middle Eastern baking soda there. And we've got some South African baking soda. So I'm sure you've got baking soda wherever you are as well. And it is a wonderful reagent for our chemistry teaching. So we're going to make something that I'm happy to say hasn't been that relevant in my lifetime, and that is a fire extinguisher. Good to know about fire extinguishers, but hopefully you'll never have to use one, okay? Now we're going to try and make a simple fire extinguisher that works on the same principle as a real fire extinguisher, or at least some fire extinguishers work by using the gas carbon dioxide to remove the oxygen. So any fire, if you're teaching combustion or you're teaching the fire triangle, any fire needs three things. We need fuel, we need heat, and we need oxygen. So in the lighter, I've got those three things. I've got a source of heat, makes a little spark. I've got some fuel inside, and I've got oxygen from the air. So I can make a fire there. Same here, I've got all my candles. I have got my fuel, which in the case of a candle is the wax. It's actually that gaseous wax vapor that is providing most of the fuel, although the wick does burn as well. I've got oxygen from the air, and I've also got a source of heat, which in this case was my lighter. Now, I think, Joe, let me know if this doesn't work, but I thought just to, I know it's late in the afternoon for some people, I thought bit of atmospherics. We might actually turn the light off.
Great idea, a bit of mood lighting, Graham. I love it.
Oh, yeah, lovely. It's a little bit romantic, isn't it, Joe?
Very.
So my wife, when I set up a nice science demonstration for a romantic dinner, she doesn't find it that relevant, but I think it's really lovely. So again, relevance, a very personal thing. Now, I'm going to take my jug and we're going to put a little bit of baking soda in there. It doesn't really matter how much, okay? If you've got too much, you're about to make a mess, but a good couple of tablespoons at the bottom, and our vinegar. Now, when vinegar and baking soda react, the new things we're making, and we'll pop a link up, or in fact, Joe, could you pop that link up to our teacher booklet? And you'll find most, if not all, of these activities in that teacher booklet, and you'll find the chemical reaction that we're about to do. So between sodium.
Oh, sorry, Graham, I was just going to say for everyone else that's in the chat already, if they scroll up a little bit, they'll see the link to that booklet.
Now, I should say that booklet is linked to the curriculum in Samoa, So our friends in Samoa, will find this incredibly relevant. For our friends everywhere else, you'll find that those links through to the Samoan curriculum, there probably are parallels in your curriculum as well. So, but if you're having trouble linking any of the activities to your curriculum, then please jump on the closed Facebook, pop up a question, and we'll see if we can solve it together as a community. But vinegar and baking soda, when it reacts, one of the things we make is carbon dioxide gas. Now that gas is heavier than air. So if I do this right, my jug should fill up with carbon dioxide and it'll actually kind of sit in there. So it is heavier than air. So I'm going to pour the vinegar in there. I can see it bubbling up. I'm going to try and kind of just make sure that gas stays in there. We're going to try and make a little fire extinguisher. Did everyone see that go out? Let's just light them up again. I can still hear that carbon dioxide being produced, all that bubbling, all those bubbles are full of carbon dioxide. Hopefully I've got enough to put out this fire. And as soon as the carbon dioxide that carbon dioxide surrounds the candle flame, the fire can't access oxygen and that combustion reaction will stop. So a lovely bit of chemistry. We've got the chemistry happening here and we've also got the combustion chemistry happening here. You don't need a whole lot of candles. I thought it'd kind of add to the atmosphere. I'm a bit of an old romantic when it comes to my science demonstrations, but if you just need one candle or any kind of, a candle works really well, but you could even just use a match or something like this. And if you want to have multiple candles, you can see this is pretty high tech. I've got some old food containers and I've put some foil on top just to, so it looks pretty, but also so that there's no fire hazard or less fire hazard there. So a lovely way that we can bring this chemistry to life. We can do it in a hands-on way with really simple items, or we can also link to everyday life. So I've called it a fire extinguisher. How it's relevant to you, or how carbon dioxide is relevant to you, or how fire is relevant to you. These are all different things, all personal questions. And it really underscores the really personal nature of relevance, and the way that different people will relate to science is different for all of them. There are some things in common, and it's understanding those things and understanding what's important to your students, being able to link to their everyday lives that's going to help them find that relevance. So once again, I'd invite everyone in the chat, if this little fire extinguisher demonstration has connected with you somehow, if it's reminded you of something, if you think it could be useful, if it's connected with your identity, maybe you're a part-time firefighter, I don't know, please pop it in the chat. We'd love to hear how this demonstration was relevant for you. All right, just while everyone's popping things in the chat, I hope it's been relevant to you. I've only had to use a fire extinguisher once in my career, which I count as a win, given things catch on fire fairly often in my job, usually at the right time, but not always. But how you connect with that fire extinguisher, or maybe how you connect with the gas that we made to put out the fire, that might be a different thing again. Okay, all right. Now, can I just get a show of hands for the people who've got their videos on? Can anybody, does anybody use vinegar and baking soda in their classroom? Anybody, it's a show of hands if people have used that. Yeah, I've got some thumbs going up. All right, okay, I've got a bodiless thumb go up on the top. But you can do great experiments with your vinegar and baking soda. around combustion, as you saw, around pressure, around lots of other things. The classic volcano experiment or activity, a really good one. One of the other ones I really enjoy with my vinegar and baking soda, and one of the reasons I find them so relevant is, number one, they're really easy to get anywhere in the world. You can get this at the supermarket. I did have an incident in Japan. I was trying to find the baking soda and everything was in Japanese characters. So they were less relevant to me and I had to guess what I was getting. Luckily, on the back of one of the packets was the chemical formula. So that was relevant to me, even though the language wasn't. So vinegar and baking soda, we can do lots of different things. With those same things, I'm going to show you another little experiment that we often call the canister rocket, okay? And this got its name through one of these little things. Now, out there, you can probably identify this as a film canister. Now, one of the things I've found, and this is showing my age and what has become relevant at different points in life, if I show this to a young person today, it's not relevant, okay? They've never seen a film camera, most of them. They sure don't know what a film canister is. When I ask their parents, they can usually identify the film canister, okay? So what's relevant is going to be different for different age groups, and it's going to be different depending on where you are. So we'll do the experiment with a film canister. I put the vinegar in the body of the canister and I put the baking soda in the top. Okay, you can see it. You can see it there in the top. And I'm going to put these together. I'd like everyone just to have a think about what's going to happen. If you're feeling brave enough to put your prediction in the chat, feel free to make a hypothesis with us. And I'm going to close the lid and we're going to have that reaction. Now, you saw before that I was able to fill this up with carbon dioxide. So a lot of gas is going to be produced. Let's see what happens. On goes the lid. More and more gas. Pretty soon, woo, pretty soon, off it goes, all right? The gas is being produced. We're making lots of carbon dioxide gas in there, and that gas builds up and it creates pressure. And you can imagine inside the container that pressure in a gas, it's operating in all directions, so pushing this way, but there's also a push this way and an opposite push that way in accordance with Newton's third law. And it's that push that pushes the lid off this way. The lid's got nowhere to go, it gets pushed into the table, but that equal and opposite force, it's what pushes the container up. So this experiment is clearly relevant to Newton's third law. It might be relevant to some other things. And I often have kids go, oh, do the rocket, do the rocket. Okay, they've linked it to something else that's relevant to them. Okay, and kids love rockets. They're exciting. I love rockets. I'm a grown-up. But that's how they connect with it. Now, the problem with our film canister, let's go and get it. Make sure I don't lose these because these are very, very hard to find. And you might be sitting there going, Graham, Joe, you promised that we were going to use everyday items. And I admit it, a film canister is not an everyday item anymore. Okay, if you've got some, pop them away, great for science teaching. But it's a good chance for us to be little engineers, okay? And in STEM, we often don't think about them all at once, the science, the technology, the engineering and maths. But when you can integrate these things, it can be really powerful ways for your teaching and powerful ways to make things relevant. And one of the things we do in engineering is we look at the properties of things, how they're built, what they're good for. Now, you don't need a film canister to do this. You just need something that has the same properties as a film canister. So it just has a lid that can pop on and off. It just needs a lid that, so when the pressure gets too high, it pops off. And there's lots of different containers that have this property. This was a little container from some medicine. And I was actually telling this story to a group of people, and they said, wow, a container with the lid that pops off, that reminds me of these containers I have at home. So it was a way that the everyday item could provoke that relevance. And the woman that gave me that feedback actually proceeded to give me a whole lot of these little containers that we used for medicine. It has a pop top lid and it should work just as well. So we'll do another one. If you want to do, does anyone want to do a little countdown at home? Just looking at the screen. So you can do a little countdown. If you like, we'll go 3, 2, 1. Pop the lid on. Woo! And off it goes, okay? And once again, I've got my carbon dioxide being produced, the pressure getting higher, and then one force pushing the lid that way, the other force pushing the container up, okay? But possibly relevant in different ways, okay? Maybe you're thinking of a pop-top container that's at your house right now and thinking about how you might try this demonstration, because it will work with lots of different pop-top containers. This one, again, you probably find it where you are. This container actually has traveled with me from Southern Africa. It's just a little vitamin container, and you'll find the Barocca, lots of other vitamins come in these pop-top containers. We'll pop the lid on. This one holds a bit more pressure and off it goes, okay? So the everyday items, not only good for making accessible teaching and bringing our science to life through hands-on methods, but also a good way to connect with people. Now, I really wanted to show you a slightly bigger pop-top container, okay? So this is a brand of yogurt that we find in Australia. You might be thinking, Graham, that's not relevant to me. I don't live in Australia, but I challenge you, the next time you're at the supermarket or the local corner store, have a look and see if you can find any containers that are a bit bigger, that have a pop-top lid, and you can probably do this demonstration. Now, I did try this outside before, and I decided that I shouldn't do this inside, but we do have a little video where we can watch it done outside.
So here we are. I'll push play now. You might not be able to hear the sound, but you'll certainly be able to see what happens.
So we've got one of these yogurt containers. It's got the vinegar and baking soda in it. You'll notice I've got some eye protection on. Please note your safety. That pressure's building up and off it goes, okay? So lovely, a lovely example and possibly relevant in a different way. So it's my challenge for everyone. I'd like you to find the biggest pop-top container that you feel safe using and give that a go. And I would just highlight, please wear your eye protection and please follow with any of these more hazardous experiments, even if it's just a little candle. Please follow any local risk assessment things you have to do. If your school requires extra paperwork or approvals, please make sure that you do that as well. And Joe and I are also very happy to help out with any safety concerns. We've deliberately picked demonstrations that aren't dangerous or have minimal risks, but please, if you've got any concerns with safety, Facebook or email and let us know, and we'll be happy to advise how you can do all of this safely. So again, we made a lovely little rocket ones, not big ones. Yes, Joe? I
was just going to say we've got a few people putting some ideas on relevance inside the in the chat. Everything from, well, using this to talk about pressure and gases to rocket science to physics and unbalanced forces. So lots of really interesting stuff coming in there. And we were talking about maths at the very start. One thing that I will say is this can be a great way to incorporate some maths or some algebra into your lessons as well. If you want to explore projectile motion, I'll chuck something in the chat that talks about identifying how high a projectile's gone based on how long it's in the air for. Some really nice physics, algebra, and maths there.
Lovely. So really thanks for that, Joe. And it's great to hear people connecting this with different parts of the curriculum, okay? These one activity, it can be relevant to different parts of the curriculum. Great you're thinking that way. And those other suggestions like rocket science, of course, you know, this is something that young people get excited about, space, you know, things launching up into the air, something that can get them really excited. So you might be thinking about relevance in terms of how can we use this so people learn more And that is really, really important, okay? Really important. As teachers, obviously, we want people to learn, but also thinking about how it's going to get people excited, how it's going to get people inspired, because all of the learning research out there shows that if we're creating a positive environment in the classroom, one where, you know, students can get hands-on and be curious, that gets them inspired, that gets them motivated, and when they're feeling like that, they learn a lot better. Okay, so we might have relevance for learning, but we're also going to have relevance that's just going to engage and get our students excited about science. So this is our second last demonstration, and one that can be, again, relevant in lots of different ways. It can link to different parts of everyday life and different parts of the curriculum. Now, you're going to need just simple things to do this. Again, we've got a little candle and I've got a balloon, okay? Simple items, and we're going to do a little experiment. Now, when I'm doing this demonstration, I really like this one as a way to highlight the scientific method. Now, all of the activities we've done today, you could make them relevant to that process of science, that idea of making a prediction, testing it, changing variables, observations, collecting data, testing hypotheses, okay? We can link to the process of science. And for me, this is a really important thing to do because we want to do a lot more than just get facts into students' heads. We want to give them tools to actually work with those facts in dynamic ways. So a scientist is a lot more than a dictionary that knows all the things in science. It actually knows how to use them, how to apply them, okay? Science at the end of the day is a tool. It's a way of thinking as well as a collection of knowledge. So thinking about the scientific method, I am going to lower this balloon towards the candle, and I'd like everyone to make a hypothesis, okay? You've probably got a rough idea what will happen. Let's test that hypothesis. We're going to go closer and closer and closer, and off it goes, okay? So no surprises there. Balloons burn, okay, and it pops. Minute the flame touches the balloon burns, and that little hole is enough for the balloon to explode. Now, something else we do in science, and we're going to do in this activity, is we change the variables in an experiment. Now, a well-designed experiment, it's often hard to do in the real world, but a well-designed experiment, we try to change one variable at a time. And this is important so that you can see the effect of it, okay? We're trying to control everything else and just look at one variable, okay? An important part of a well-designed experiment or a fair test. I've got another balloon here, and you might be able to notice that this balloon is behaving a bit more differently. And if I bring it over to the camera, you might be able to tell that there is something in it at the bottom. I'll give you one more clue. So you've probably all guessed at this stage that this balloon has some water in it. So I popped it on the tap. I filled it up until it's about the size of a grapefruit. I'm just hoping that everyone has grapefruits where they are. That might not be a relevant analogy for you, but a ball about this big, okay? So once you've got that water in, then you take it off the tap and blow the rest of it up. So you've got air and water. So compared to our last balloon, the variable we've changed is what's inside the balloon, and we've added some water. So I'd like you all to make another prediction about what's going to happen. You all saw what happened there? Maybe I might just put this here just to make sure we collect all that mess. So we're going to lower it down. And just if you've got a camera on, just a show of hands, hands up if you think it's going to explode. Water's going to go everywhere. Anyone? I see some thumbs. Okay, hands up if you think that won't happen. Got any thumbs? Oh, we've got a couple of people. Oh, 3 I can see. All right, and hands up if you don't know. Joe Duggan. Okay. It's okay. It's okay if you don't know, because that's why we do science experiments, to find out that stuff. So let's lower it down. And just to make it interesting, I'm going to time how long it takes. I've got a little stopwatch here. And as soon as it's touching that flame, I'll start my stopwatch. I won't start the stopwatch, it's broken. We'll just lower it down there and we'll just kind of see how long we can hold it there. Now you'll see, or hopefully you can see, that the fire is actually touching the balloon. If you can't see the fire touching it, you should be able to see that on the bottom of the balloon. But this time it is not popping. And we can hold this balloon here for quite a while. Now you can make this a little bit more exciting for people by doing a little demonstration where we can hold it above there. I'm not going to do that because I can't quite see myself, but you can make it a little bit more exciting. But it's pretty amazing that the balloon doesn't pop. Now, because we've used the scientific method, it's easy to work out, well, it must be the water that stopped it popping, because that's the only difference between these two experiments. And the water is really good at absorbing heat or taking in heat. We say it's got a high specific heat, which means that it can take a lot of heat in without getting too much hotter itself. The water still feels nice and cool in there, even though the water has been absorbing all of that heat from the candle. So water, very, very good at cooling, and good thing too, we can talk about specific heat capacity of water, all those kind of things. Now, again, I'd love to hear how this is relevant to you. Perhaps you use this property of water in other places. Perhaps it links with you in a different way. So if you can think of a way this is relevant, maybe a way that you've used this idea, an area of everyday life where we use the fact that water is very, very good at absorbing heat and cooling things down. For me, that's a lovely, if I'm hot day, Australia gets very, very hot, down at the beach or down at the dam, it can be hot in the air, I can jump into the water, and because the water is so good at absorbing heat, I'll cool down nice and fast, okay? Something we've probably all experienced, and something that I think about when I think about the heat capacity of water, I think, oh, it's just so refreshing. How it links to you, I don't know, but let us know in the chat. All right, lovely. So I'm just going to get my last demonstration out. If you've got any other ideas of how this was relevant to you, we'd love to hear them. And I'm going to get my final little demonstration.
We've got a few people in the chat talking about energy transfer and heat transfer, which is great to see. One of my favourite ones, Graham, is we talk about exactly as you say, jumping into the water. In a lot of the places that you and I have both worked in the past, are very sunny places that are often near the ocean. And so a lot of the children that we work with can relate to running around, being very, very hot, but then being able to cool down quickly if they jump in the water.
Lovely. Thanks for that, Joe. Great. All right. We're going to move on to our last demonstration. And I should say that this is one that does have some hazards. So if you are trying it, please do have a good read of the procedure in the activity book that Joe shared the link for earlier, just to make sure you're observing all the safety precautions, of course, wearing some eye protection, making sure that you have a fire extinguisher. You should have a fire extinguisher, not one made of vinegar and baking soda, or whatever other precautions that you have when you use something like fire in your teaching. But for our last little relevance demonstration, I've got this old coffee tin, okay? Make sure it's a metal tin because we're going to make a fire in it. Now, I'm going to give you a little clue about a little relevance clue. And the clue is that this is, what shape is it? Joe, can you help me out here?
I'd call that one, Graham, a cylinder.
A cylinder, okay, I probably would too. So there's your little clue, how it might be relevant. Now in this cylinder, we're going to perform a combustion reaction, okay? And I've got the things that I need. I've got some oxygen in there, okay, the things for my fire triangle. To start our fire, I'm going to use my little lighter, and you might see I've made a little hole in the bottom of the tin there, okay, just a little hole. You can just use some scissors or a drill, just take care with that step. And I've just made a tiny little hole in the bottom there, okay. Now, the other thing I did is to calculate the volume. So this tin holds about 1.5 litres of air. And in that air, I've got about 20% oxygen, okay? So a great example of putting our chemistry and our maths, okay, the M in STEM, put our chemistry and our maths together. We can work out the volume. From that, we can work out the amount of oxygen in there. And from that, using our maths and the chemical equation together, we can calculate the volume of fuel that will react with that oxygen. There's some wonderful maths in there to work out how much fuel we need for this amount of oxygen. And again, we'll share something on the Facebook page. Just make myself a little note. We'll share something on the Facebook page that can help you if you want to use this to calculate the amount of fuel by volume or by maths. You can do some wonderful mathematics to work it out. Now, when I did that maths with 1.56 litres of air, and then only about 20% of that is oxygen, I can then calculate that I will need that volume, 49 mils of fuel I'm using. Now, the fuel I'm using is a mystery. Now, I'm going to show you what it is because I want it to be relevant to you. I have got just a disposable butane canister there, okay? You can get them in most countries. I want that to be relevant to you because I'd like you, if you'd like to use this demonstration in your schools, but I don't want this to be relevant to students in that way, okay? We've got to think about, especially if we're using more hazardous demonstrations in our teaching, just thinking about what's going to keep the students safe. So as a bit of a precaution, I don't show the students what this can is. They might work it out, that's okay. But we do want to think about the safety. So using our maths and our chemistry together, I know I need 49 mils of my fuel. I'm going to pop the lid on. I'm going to put a little bit of, I've just put a bit of plasticine on here so the lid doesn't go too far, and I'm going to measure out my fuel. I'm using a little syringe. I just got, this was an old one that I was able to get from a hospital, or sometimes a veterinarian. They might have an old syringe, okay? And I've got about 40 mils in there. Pop it in our little hole. And I'm going to get a little bit more. So I'm up to that 49 mils. Okay. Now I've got my fuel, I've got my oxygen, I just need my heat. Woo. Wonderful. Okay, and oh, okay, did you see the fire come out the top? Yeah. So we've got a lovely combustion reaction. Like we've talking about before, we've created a lot of pressure. As that fuel burns, it creates a lot of hot gas. In fact, it creates a larger volume of gas than what we started with. So that's the first thing that is increasing pressure in the tin. We've got more gas, more moles of gas in the products than the reactants. So that's got to increase the pressure. The other thing that's increasing that pressure is that we're creating a lot of heat, okay? As that gas heats up with the heat from the combustion, it expands as well. So there's two things creating pressure. Number one, we've made more gas than we started with. Number two, that gas is hot and therefore it takes up a larger volume, okay? Those two things end up creating a nice force on our tin, and it lifts our lid up. Could be relevant to lots of different things. Have a think about connections you might make, and you can pop them in the chat. But while we're doing that, you might have been looking at this and said, Graham, this is not an everyday item, okay? And in a lot of ways, they're not, okay? We certainly don't want to encourage our students that if they see a syringe or something on the ground, that they touch it. And there's one of these places where where relevance can be negative or relevance can be good for safety, okay? But if you can find clean, safe syringes, you can use them in this demonstration. Now, if this isn't an everyday item for you, you can use other fuels, okay? You can kind of guess the amount. You could just squeeze some of that in there. I've got another fuel in here, and once again, I've covered it up. The fuel I've got in here is a mixture of flammable gases like I had in here, butane and propane, and it's also got some ethanol in it, okay? And you might be looking at this going, wow, butane, propane, ethanol, this is not relevant to my everyday life, but I promise you that many of you will know what this substance is, okay? It's hairspray, okay? It's hairspray. Don't tell your students, because again, we don't want them trying this at home. But we've just got hairspray, okay? I hope it's relevant to you. You should be able to find it locally. We can also do this with our hairspray. Just find where the lid of my cylinder's gone. This down here. Okay. And we can do the same thing. We can spray a little bit of our fuel in. Don't need much. Just need the right balance of fuel and oxygen. Okay, I've just guessed a couple of little squirts and we should get a nice little reaction again. Woo! Obviously, guessed that really well. We've created lots of heat, lots of pressure, and we've used that pressure to do some work to apply quite a decent force to this. And don't tell my boss, but I've applied a little bit of a force to the roof in my office as well, but that's okay. All right. So once again, have a think how it could be relevant. I'm going to give you a little clue. We gave you one before in the shape of this. I don't know if anyone drove to work today, but it could be relevant in different ways as well. So once again, if you want to pop in the chat where you found relevance in this, how it links to everyday life, how it might be useful, how it connects with your identity, please pop it in the chat.
We have one here, Graham, from some of our friends in the Philippines saying that they have a cannon toy that works like that in the Philippines called a lantaka or a boga. I hope that's right. But it actually reminds me of some Fijian colleagues that have something called a dakai bitu, which is a very similar thing made out of bamboo, uses exactly the same principle. So that's really exciting to hear.
That is wonderful. As you might have guessed, I do like a little bit of explosive STEM, and it's wonderful to hear how people are using these ideas in their culture, and these cultural artifacts that go way back before we had things like internal combustion engines and things like that. They were things that are being useful. They're being relevant. Okay, so thank you for sharing that. It's a great example of where the way that relevance manifests in different countries is very different, okay? I know that there's, as Joe said, a version of these little cannons in Fiji. There's another one where when I've worked in Timor-Leste, they have another version as well that they make with special bamboo that is incredibly strong. So lots of different ways that this idea is reinterpreted and made relevant depending on the culture that you're in. Now, this could be relevant in different ways as well. Often I use this demonstration in a show where I talk about carbon dioxide emissions and climate change. If we're talking about carbon dioxide emissions from transport, this is a really good example. We've got a cylinder, It's a pretty good model of what's happening in an internal combustion engine. So we could certainly use it to teach that. It's part of the curriculum in a lot of places. But the relevance I find in this is that this shows us some of the things that we need to change in the future, and some of the things that are doing damage to our planet and heating up the planet. So again, there's different ways that we can take the same very simple but exciting piece of equipment, connect it with different parts of the curriculum and make it relevant in different ways. Some of them quite profound. Okay, lovely. Look, we've come to the end of these little demonstrations. So we've looked through a whole lot of things. I hope they've been a useful exercise for you, not only to think about some hands-on science you can do with simple items, and this is a powerful way to get students engaged, powerful way to bring your science teaching to life. Of course, do it safely. But I hope it's also given you some ideas about how you can connect your science teaching, not just the curriculum. It's certainly relevant. We need to be relevant to the curriculum when we're using our hands-on stuff, but how we can connect in different ways, how we can connect the science in the classroom with what students are observing and doing in their everyday lives, how we can connect the science in the classroom to things that might be useful. You might have a student see this and think, wow, I know how to fix my friend's motorbike, or I think there's too much fuel and not enough air, okay? I can go and use this information somewhere else. And finally, hopefully it's connected with you in deeper ways. It's not for me to say how it should connect with you in deeper ways, but thank you for people who've shared on the chat, particularly those deeper ways where it's connecting with the place you're in, your culture, your Indigenous knowledge, all these other kind of things, because it's those special connections, those really specific connections that students are going to find the most motivational. So the closer you can get to linking your STEM to things that are really important to your students, whether that's pop culture or a sport or something they're passionate about, like the environment and reducing carbon emissions. These are ways that we can really show why science is important, why it's useful, and these are all ways that are going to help people learn better and be more inspired as they learn that science. So I hope it's been useful for you, and thank you for all your interaction in the chat. I can't quite see everything, but I can see it whirring through lots of wonderful examples, and I'd really encourage you to keep thinking about it. Joe will circulate that Facebook page that we all saw before, and we'll also send you a little bit of a follow-up survey. If you can, we'd be really grateful if you do complete that survey, and we'll actually get a link to, I'll speak with Joe, but a certificate that you can download, possibly that will come through the survey, or we might post it up in the Facebook group, probably through the survey. And thank you for that bit of feedback. If there are other things that we can do to make the workshop series more useful for you, whether it's a certificate, whether it's other things, please let us know through the survey or through the Facebook group. We'd really welcome your input.
Beautiful. Can everyone please join me in either giving a real or a virtual round of applause for Graham? He's our very first presenter as part of this series, and we are going to have a whole bunch more experts in a whole range of fields coming in as part of this, sharing their knowledge. And what we really want to get is this two-way communication as well. So I reiterate Graham's call to join the closed Facebook group. You'll see everything we do if you join our normal Facebook group, and we want you to do that. But we also want a way to be able to talk to you directly. So the link in the chat there for the closed Facebook group, and that's something that we'll send around in an email as well. All right, everyone. Thank you very much for your time. Stay tuned to your emails and to Facebook, and you'll see when the next one of these is going to happen. Fingers crossed, at this stage, we're hoping in a couple of weeks. And if you have strong feelings about the timing, let us know that as well. Thank you so much for your time. Graham, anything else to add before we finish?
No, just wonderful to see people from all over the place, and we'd love to see these ideas going back into your classroom. And what we'd love even more is to hear those stories. So if you go and try these demos, if you're using them in the class, share through the Facebook, send Joe, send I an email. We always love to hear how teachers are using the ideas. Equally, if you're having challenges or you need different demonstrations, feel free to get in touch, and to really encourage these ideas to go into the classroom. Just highlight what Joe said before, towards the end of the workshop series, we will be running a series of micro grants. So we've got 20 schools that we'll be giving out 150 Australian dollars to kind of supercharge their science teaching. And we'd love some of the people on the call today to be part of that grant round.
Brilliant. Thank you very much, everyone. I've just seen too, is it Ayu has a balloon there? Have you been doing the experiments? Yes, got all the materials. Great to see. I'm very pleased. All right, everyone, thank you so much. You'll be hearing from us shortly, and I hope you have a good afternoon, evening, or morning, wherever you are in the world. Thank you very much.